The Black Swan. What is a black swan? A black swan is photographic or observational evidence that shows the horizon behind an object that is beyond the physical geometric horizon of a sphere. The distances involved are based on a mathematical geometric calculation that uses the radius of the sphere and the observer's height. The calculation is an accepted and proven mathematical formula. If you are not familiar with the black swan phenomenon, then the above description might sound vague and unclear. A visual representation will now follow that will hopefully put the above description into a more understandable manner. A man standing on a sphere would observe the physical geometric horizon at a certain distance, which on the diagram is represented by the red and yellow circle. The physical geometric horizon is the maximum distance that the sea and sky can be observed to meet. This is what is observed. No imaginary other horizon or second horizon where the sky and sea meet can be observed past the line of the physical geometric horizon represented by the red and yellow circle. Why is there a physical geometric horizon? Obviously, you cannot see around a sphere. Due to the geometric shape of a sphere, there is a specific maximum physical distance an observer can see that is determined by the height of the observer and the size of the sphere. This maximum distance is called the physical geometric horizon. If we live on a physical geometric globe of known circumference with a radius of 6,371 kilometers or 3,959 miles, then the physical geometric horizon, the line where the sea is observed to meet the sky, must be at a specific distance for an observer at a certain height. No imaginary other horizon or second horizon where the sea meets the sky again can be visible past the physical geometric horizon, because the physical geometric horizon is where the sea is observed to meet the sky. Obviously, on a sphere or globe, the sea is only observed to meet the sky once. What about weather and optics? Misty, foggy, etc. conditions can prevent the observer seeing the physical geometric horizon. The observer no longer sees the physical geometric horizon, represented by red and yellow circle, but rather an apparent horizon, represented by the black and white circle. Apparent meaning seeming real or true, but not necessarily so. This is what is observed. The quality of the optical device being used will determine whether the observer can see the sea meet the sky at the physical geometric horizon. If the optical device does not permit the observer to see the sea meet the sky at the physical geometric horizon, the observer will see a closer apparent horizon instead. Do you see the boat, Granddad?
See the boat? I can't see the end of my own nose without my glasses.
Observation of Rampion Wind Farm. Rampion Wind Farm. Located between 8 and 16 miles from the shore, the wind farm is situated off the coast of the towns of Worthing and Shoreham by the sea to the west, the city of Brighton and Hove in the center, and the towns of New Haven and Seaford in the east. The wind farm lies in a zone that is an irregular, elongated area, approximately 17 miles in an east to west direction and approximately 6.2 miles in the north to south direction, an area of 27.8 square miles. This observation is going to focus on the 6 wind turbines represented by the red dots. For sake of keeping the numbers simple, it shall be stated that the red dot wind turbine closest to the shore is at a distance of 8 miles from the observer, and the furthest red dot is at a distance of over 11 miles from the observer. The 6 wind turbines will be labeled from 1 to 6 to indicate their increasing distance from the observer, 1 being the closest and 6 being the furthest. The Black Swan modus tollens. If the Earth is a sphere with a radius of 3,959 miles, then every horizon distance measurement must be no more than 1.225 times the square root of the observer's height in feet. Geometric horizon curve calculators. The lens of the camera was 2 feet above the tide level. Accordingly, the distance to the geometric horizon is square root of 2 times 1.225 equals 1.73 miles. The geometric horizon is 1.73 miles away from the camera. So with the camera 2 feet above tide level, the geometric horizon is 1.73 miles away from the camera. What should not be observed at a distance of 8 to 11 plus miles? The bottom of the wind turbines meeting the sea should not be observed. The horizon behind the wind turbines should not be observed. If the bottom of the wind turbines meeting the sea should not be observed, then the low tide mark meeting the sea will not be observed in the video footage. Here we see the high tide mark and a low tide mark. Photograph of Rampion Wind Farm at low tide. High tide mark and a photograph of Rampion Wind Farm at high tide. Weather information, Thursday, 6th of August, 2020. The weather leading up to the observation. Tide data, Thursday, 6th of August, 2020. Low tide at Worthing on Thursday evening was at 7:55 p.m. The observations were made between approximately 6:56 p.m. and 7:30 p.m. The tide level above lowest astronomical tide at 7:15 p.m. was approximately 1.10 meters. The sea was very calm indeed, and there was little or no wind. It was the clearest and calmest day I had ever witnessed. 2 observations were recorded with a P900. Let's see what the observations show. The original uploaded videos can be viewed at these links. The links will be in the description. What was observed? From observing the video footage, it can be stated: A. No refraction in the form of an inferior mirage was observed. B. No refraction in the form of a superior mirage was observed. C. The images of the wind turbines are well defined with limited heat distortion at the distance filmed. D. The sea is very calm. How the video footage will be presented. 1. A number of screenshots will be taken from the video. 2. The screenshot will be directly copied and pasted into a PowerPoint slide. 3. The size of the screenshot will not be changed in any way. No vertical or horizontal stretching of the image has occurred. 4. Any image manipulation in terms of brightness, contrast, etc. will be stated. 5. Please validate what has been stated here by double-checking. 6. Please take your own screenshots and manipulate them. Note: the term globe Earth, when it is used, means a globe with a radius of 6,371 kilometers or 3,959 miles. Screenshot taken at time 137. The first windmill is 8 miles from the observer, and the sixth one is over 11 miles from the observer. Distance of turbines from the observer. 1 is 8.4 miles, 2, 8.8 miles, 3 is 9.3 miles, 4, 9.8 miles, 5, 10.8 miles, and 6 is 11.2 miles from the observer. All figures have been rounded up. The image manipulation is at contrast 75%. What is the hidden height for an observer at a height of 2 feet and a distance of 8 miles? The hidden height is 26 feet or 8 meters. What does hidden height actually mean? If Earth was a globe with a radius of 6,371 kilometers or 3,959 miles, then the physical geometric horizon, the line where the sea is observed to meet the sky, would be 1.73 miles from the observer. Past this point, the bottom of objects will begin to not be seen as the observer cannot see around the globe. This is termed the hidden height, as represented by the light green section in the diagram below. The further the object behind the physical geometric horizon, the higher the hidden height. Note: this wind turbine is smaller due to perspective. It is further from the observer. The horizon is behind all the wind turbines, distance 8 to 11 plus miles. The bottom of the turbines can be seen here meeting the sea. There is no hidden height. A screenshot taken at time 137, image manipulation contrast 75%. At 8 miles and a 2-foot observer height, the hidden height is 26 feet or 8 meters. Manipulate video screenshots how you wish and see what you get. The horizon is behind the substation, 8 miles from the observer. The bottom of the substation can be seen meeting the sea. There is no hidden height. Screenshot taken at time 1348, image manipulation contrast 75%. A support vessel working around the wind turbines. What is it? Screenshot taken at time 728, image manipulation contrast 75%. Wind turbines 8 miles from observer. The support vessel, the Pacific Worker. The Pacific Worker on myshiptracking.com. The Pacific Worker dimensions. Note the depth is 9.13 meters. Note the size of the men and deck rails and these 3 white markings. At 8 miles and a 2-foot observer height, the hidden height is 26 feet or 8 meters. By comparing the white markings on the ships in the two images, it is obvious that there is no hidden height of 26 feet or 8 meters in the top image. Note, the Pacific worker in the top image probably looks lower in the water because of perspective. It is 8 miles away and its deck is loaded with items. Use the man as a height guide. Conclusion. There is no observed hidden height of the wind turbine bases and substation legs in the video. The horizon is observed beyond the furthest wind turbine, the substation, and the physical geometric horizon. This image is not possible on a globe with a radius of 6,371 kilometers or 3,959 miles. The other observation now follows, recorded with a P900. Please note, the lens of the camera was 3.5 feet above tide level. Accordingly, the distance to the geometric horizon is square root of 3.5 times 1.225 equals 2.29 miles. The geometric horizon is 2.29 miles away from the camera.
What's that one? Oh, hello. What's the roof of that way?
What was observed? From observing the video footage, it can be stated A. No refraction in the form of an inferior mirage of a wind turbine was observed. B. No refraction in the form of a superior mirage of a wind turbine was observed. C. The images of the wind turbines are well defined with limited heat distortion at the distance filmed. D. A superior mirage of a ship is observable. E. The sea is very calm. Distance of turbines from the observer. 1 is 8.4 miles. 2 is 8.8 miles. 3 is 9.3 miles. 4 is 9.8 miles. 5, 10.8 miles. And the sixth turbine is 11.2 miles from the observer. These figures have been rounded up. The screenshot was taken at time 11:22, image manipulation, contrast 75%. The bottom of the turbines can be seen meeting the sea. There is no hidden height. The horizon is behind all the wind turbines at distance 8+ miles. Screenshot taken at 11:27, image manipulation, contrast 75%. The bottom of the substation can be seen meeting the sea. There is no hidden height. The horizon is behind the substation. The substation is 8 miles from the observer. A ship is observed behind wind turbine 3. A screenshot taken at 9 seconds. Now behind wind turbine 4. Screenshot taken at time 25 seconds. Image manipulation, contrast 65%. Now behind wind turbine 6. Screenshot taken at time 30 seconds. The ship is behind wind turbine 6. The bottom of the turbines can be seen meeting the sea. There is no hidden height. The horizon is behind all the wind turbines. Distance 8+ miles. Screenshot taken at time 40 seconds. What ship is that? The Shetland Trader. Notice the depth is 5.5 meters on the Shetland Trader. The Shetland Trader's route was observed on myshiptracking.com. The Shetland Trader's route took it behind the wind turbines. Marine traffic allowed distances to be measured. 12.1 nautical miles equals 13.9 miles. What is the hidden height for an observer at a height of 3.5 feet and a distance of 13.9 miles? The hidden height is 90 feet or 27 meters. What would a hidden height of 90 feet or 27 meters look like? We shall assume that the man on deck is 6 feet or 1.8 meters tall and use that as an approximate height guide. Note the position of the circle symbol. The height of the ship is 7.2 meters or 23.6 feet. With a hidden height of 90 feet or 27 meters, the ship would not be visible on a globe with a radius of 6,371 kilometers, 3,959 miles at the distance observed. The horizon is definitely behind turbine 6. Is it behind the Shetland Trader? Your call. Conclusion. There is no observed hidden height of the wind turbine bases and substation legs in the video. The horizon is observed beyond the furthest wind turbine and the physical geometric horizon. This image is not possible on a globe with a radius of 6,371 kilometers or 3,959 miles. Bonus features. At 27 seconds, approximate time 6:57 p.m., into the video, the Shetland Trader is seen passing wind turbine 6 on the right-hand side of the wind farm. At 1 minute and 16 seconds into the video, the Shetland Trader has clearly passed the last wind turbine on the right-hand side of the wind farm. The ship is 13.9 miles away from the observer. But what is that coming behind the Shetland Trader? Another ship? At 3 minutes and 4 seconds, approximate time 7:01 p.m., another boat is passing the last line of wind turbines on the right-hand side of the wind farm. What ship could this be, and at what distance is it from the observer? MyShipTracking.com was used to find which ship was behind the Shetland trader. Marine traffic allowed routes and distances to be measured. 18.1 nautical miles equals 20.8 miles. The Eagle Kinobaloo is a crude oil tanker, a significantly sized ship. The Eagle Kinobaloo. Note the depth is 21.3 meters. What is the hidden height for an observer at a height of 3.5 feet and a distance of 20.8 miles? The hidden height would be 228 feet, or 70 meters. Visualizing a hidden height of 228 feet, or 70 meters. The average two-story house is between 18 to 20 feet. My house was measured and is 20 feet, or 6 meters tall. A typical two-story house having a height to the roof of 20 feet or 6 meters. A hidden height of 228 feet or 70 meters would be 11.5 two-story houses in height. The Eagle Kinobaloo. With a hidden height of 228 feet or 70 meters, the majority of the ship would not be visible whether it was loaded or unloaded. Screenshot of the Eagle Kinobaloo from the video, time 3 minutes and 4 seconds. Is the horizon visible behind the Eagle Kinobaloo that is a distance of 20.8 miles from the observer? Your call. Table of observation for reference. Here's a list of the wind turbines, their distances from the observer, and what is observed in the video. For those with an eagle eye, the Shetland trader is displaying a superior mirage, an inverted image above the object. The Shetland trader only has one set of windows. What is a superior mirage? A superior mirage is an uncommon optical phenomena that is caused by a temperature inversion that results in the refraction of light in a downward direction. What is a temperature inversion and what causes one? Within the troposphere, 0 to 11 kilometers, the general trend is that air temperature decreases as altitude increases, on average by about 6.5 degrees Celsius per kilometer, which is called the lapse rate. The Earth's atmosphere is either reflective or transparent, depending on the wavelength of the radiation it encounters. As a result, the atmosphere receives little direct heat from solar radiation. It is the absorption of sunlight, electromagnetic radiation, by the land and sea, and the transfer of thermal energy from the land and sea by conduction, convection, and radiation that heats the atmosphere. This results in the atmosphere being warmer the closer it is to the Earth's surface. Causes of temperature inversions. Normally, air temperature decreases at a rate of 6.4 degrees for every kilometer you climb into the atmosphere, which is called the lapse rate. When this normal cycle is present, it is considered an unstable air mass, and air constantly flows between the warm and cool areas, and air is better able to mix. During an inversion episode, temperatures increase with increasing altitude. The warm inversion layer then acts as a cap and stops atmospheric mixing. This is why inversion layers are called stable air masses. They occur most often when a warm, less dense air mass moves over a dense, cold air mass. This can happen, for example, when the air near the ground rapidly loses its heat on a clear night. In this situation, the ground becomes cooled quickly while the air above it retains the heat the ground was holding during the day. Temperature inversions can occur when a layer of warm air spreads over a cold body of water, or in some coastal areas, because upwelling of cold water can decrease surface air temperature and the cold air mass stays under warmer ones. Temperature inversions have only been touched on here. Suggested websites follow. How a superior mirage is produced. Light rays from the sun are reflecting off the ship. Due to the dense layer of air, the rays of light that would take the path of the green ray under normal conditions are reflected downward, changing direction towards the denser medium, the air nearer the sea, as illustrated by the red ray. Due to the downward refraction and the human brain working on the premise that light travels in straight lines, the observer will see an image at the end of the blue dashed line of the ship inverted and above the actual real ship. The fish tank contains sugar solution. The sugar solution is denser at the bottom and less dense at the top. The laser beam begins to refract in a downward direction towards the more dense medium as it obliquely enters the fish tank. As it travels through the sugar solution, the direction of the laser beam continually changes or refracts towards the more dense section of the medium. The same situation is occurring in the ship situation, shown top right, that results in the observation of a superior mirage. Why is a superior mirage inverted? Light rays from the sun reflect off the ship. Some of these reflected light rays are reflected in an upward and outward towards the observer direction. As the rays of reflected light travel upwards, they are continually refracting in a downwards direction relative to their prior path of travel. The reflected rays enter a layer with a significant less density, resulting in the rays of light being refracted to an even greater extent in a downward direction. Due to the downward refraction and the human brain working on the premise that light travels in straight lines, the observer will see an image at the end of the blue dashed line of the ship inverted and higher up than the actual real object. The observation of a superior mirage indicates that a particular density gradient is present. Usually warmer, less dense air is above cooler, more dense air. A superior mirage indicates that a portion of the reflected light that is traveling in a diagonally upward direction towards the observer is being refracted in a downward direction relative to its prior direction of travel. This type of refraction produces a superior mirage. The refracted image is always observed inverted and above the object. This section is going to present the logical antecedent for an inferior and superior mirage. Inferior mirages. The car in the photograph appears to have launched itself into the air and the boat seems to be above the actual sea. The above are classic examples of an inferior mirage. What causes an inferior mirage? Light passing at an oblique angle through a density gradient of a transparent medium will change its direction of travel. In such a situation, the path of light refracts, or changes direction, towards the more dense medium as demonstrated in the diagram above. We have all seen the inferior mirage of a car on the road. The sunlight reflecting off the car and passing through the density gradient is refracted in an upward direction and into the observer's eye as illustrated below. Two conditions must be fulfilled for the simultaneous observation of an object and the inverted image or inferior mirage underneath the object across a flat level surface. 1. The light reflecting off the object must travel in a direct straight line into the observer's eye. 2. Light reflected off the object going in a diagonally downward direction towards the observer must be refracted in an upward direction into the observer's eye. If the light traveling in a straight line is blocked from reaching the observer's eyes, then A. The inverted image or inferior mirage will be observed. B. An area of the object will not be observed. Note: The block must be suspended slightly above the ground. If it was on the ground, it would prevent the inverted image from being seen. If the light that is being refracted in an upward direction is blocked from reaching the observer's eyes, then A. The inverted image or inferior mirage will not be observed. B. The object will be observed. The logical antecedent for the simultaneous observation of an object and the inverted image or inferior mirage underneath the object across a flat level surface is 1. The light reflecting off the object must travel a direct straight line into the observer's eye. 2. The light reflected off the object going in a diagonally downward direction towards the observer must be refracted in an upward direction into the observer's eye. This can be tested by anyone. It is a very simple method. The same logic and reason will be applied to the superior mirage. Superior mirage on a winter morning in the Mojave Desert, 29th of December 2006. Please note that the land is flat and that the image is not taken over water. The section with the arrow pointing at it will be used. Observing a superior mirage. 2 conditions must be fulfilled for the simultaneous observation of an object and the inverted image or superior mirage above the object across a flat level surface. 1. The light reflecting off the object must travel in a direct straight line into the observer's eye. 2. Light reflected off the object going in a diagonally upward direction towards the observer must be refracted in a downward direction into the observer's eye. If the light traveling in a straight line is blocked from reaching the observer's eyes, then A. The inverted image of the superior mirage will be observed. B. The object will not be observed. If the light that is being refracted in a downward direction is blocked from reaching the observer's eyes, then A. The inverted image superior mirage will not be observed. B. The object will be observed. The logical antecedent for the simultaneous observation of an object and the inverted image or superior mirage above the object across a flat level surface is 1. The light reflecting off the object must travel in a direct straight line into the observer's eye, and 2. Light reflected off the object going in a diagonally upward direction or towards the observer must be refracted in a downward direction into the observer's eye. Test it for yourself. The overarching logical antecedent for both an inferior and superior mirage is that the observer must be able to see the actual object with a direct straight line of sight, whilst at the same time seeing the inverted image above or below the actual object. The observer must see the actual object, not an image of the object. The importance of this will become clear. This section is going to illustrate that if you see an object with the superior mirage and the object is hidden from view using the mathematical spherical geometry, the observation cannot be occurring on a globe Earth with the radius of 6,371 kilometers or 3,959 miles, according to A. The statement or belief that on a globe Earth the sea looks flat to an observer because of refraction. B. The known laws and principles of light. C. The overarching logical antecedent for both an inferior and superior mirage. I apologize, this section will be technical and very dry. The man in the sea cannot directly see the ship or the object behind the curve. The boat is beyond the physical geometric horizon and in the hidden height zone. A person says, but the observer could possibly see a ship and a superior mirage on an assumed globe Earth because light is refracting around the curve. Let's examine this and determine what the observer would see. The black ray of light refracts in a continued downward direction around the curve. the black ray of light enters the observer's eye whilst refracting in a downward direction. The human brain, working on the principle that the light travels in straight lines, sees an inverted image of the object as shown in the diagram. If an inverted image was seen, it would have to be the inverted image part of a superior mirage. How would the non-inverted part of the superior, the actual object, be seen? Obviously, the actual object, which would be the ship, cannot be seen with a direct straight line of sight by the observer, so this cannot occur on a globe Earth, but let's see where this leads. The person says, a second ray of light is also curving around the hill and into the observer's eye, producing the non-inverted image of the superior mirage. Let's explore that. The yellow ray will be the second ray. The yellow ray of light reflecting off the ship refracts in a continued downward direction around the curve and enters the observer's eye whilst refracting in a downward direction. The observer would see an inverted image, not a non-inverted image, since the ray of light was refracting in a downward direction as it entered the observer's eye. What would the inverted image look like? The two rays of light, black and yellow, have entered the observer's eye whilst refracting in a downward direction. Each ray of light will produce an inverted image of the object based on the fact that the human brain works on the principle that light travels in straight lines. Two inverted images not in sync, seen as one slightly fuzzy inverted image, would be observed. Have you ever seen an inverted image by itself hanging in the sky rather than a superior mirage consisting of the object with an inverted image above it? No, me either. This demonstrates that all the rays bending around a curve and entering the observer's eye in a downward direction cannot produce what we see in real life. Could this work in any other way? We will try one ray of light entering the eye in a downward direction to achieve the inverted image and one ray of light entering the eye in a straight line. The black ray is refracting in a downward direction into the observer's eye and produces the inverted image. The yellow ray is refracting in a downward direction during the start of its journey, but then finishes traveling in a straight line horizontally into the observer's eye. So what would the observer see? On a globe Earth, if the sea has to be seen as flat and level to the observer, then the yellow dot must be seen at point X because the stern of the ship must be seen along the straight dashed blue line from the observer's eye. This creates an untenable optical situation that can never produce the real-life observations to support it. Stating that the Earth is a globe and then making the sea look flat to the observer because it is observably flat breaks the optics based on the known and accepted laws and principles of light. Raising the sea to be flat and level on the globe model causes the stern of the ship, which must optically be seen at the end of the blue dashed line, to look like it is low in the water or even sinking. This is never observed. Rays of light are not refracting and behaving in this manner. The second of the possible two images that could occur if the rays of light refracted in this way is shown below. On the globe model, the sea physically curves away from the observer, but is said to be seen as flat and level. If according to this model, the sea must be observed as flat and level, then the yellow dot has to be seen at point X because the stern of the ship must be located along the straight dashed blue line from the observer's eye, since the yellow ray of light traveled in a straight line horizontally into the observer's eye. In order for the ship not to look like it's sinking as displayed in the previous slide, the optics would have to be forced to fit the model by reducing the size of the image of the ship. But that would result in the image of the object being visually smaller in dimensions than the inverted image of the superior mirage. In reality, the observed object and the inverted image of the superior mirage are approximately the same dimensions. On a globe Earth with a radius of 6,371 kilometers or 3,959 miles, it is just not possible following the known laws and principles of light to see a ship, the object, that is hidden around the curve as the non-inverted part of a superior mirage. Stating that the sea is actually curved but looks flat to the observer because it is refracted causes the optics to predict the formations of images that are never observed. When we experience a superior mirage, 1. The object, the ship, itself does not look like it is sinking. 2. The object and the visible parts of the inverted image are the same dimensions. The object is not smaller than the inverted image. The conditions imposed by the globe Earth model prevents the optics from reproducing real-life, everyday images observed and recorded. The overarching logical antecedent for both an inferior and superior mirage is that the observer must be able to see the actual object with a direct line of sight, whilst at the same time seeing the inverted image above or below the actual object. The observer must see the actual object. All observations will show the object below the inverted image. The logical antecedent for a superior mirage cannot be fulfilled on a globe Earth. The image to the right is of the Shetland trader and its superior mirage. At a distance of 13.9 miles from the observer, the ship is hidden behind the curve by 90 feet or 27 meters. The object, the ship, under the inverted image would not be visible if we lived on a globe Earth, but it is clearly visible. Why else cannot you observe the object of a superior mirage on a globe Earth? If two rays of light, the yellow and black, are both refracting in a downward direction into the observer's eye, then the fuzzy double inverted image situation would be observed. This is never observed. This also means that the object and an inverted image above the object known as a superior mirage would not be observed. So, in an attempt to make the optics work on a globe Earth model, the situation has to be changed so that one of the rays is traveling in a straight line into the observer's eye. But that produces the two scenarios shown below, neither of which fulfill the logical antecedent for a superior mirage or are ever observed. And anyway, on a globe Earth, it is not possible for light refracting downward around the curve to then travel horizontally into the observer's eyes, as the next slide will show. As can be seen in the diagram below, before the light enters the observer's eye, it passes from a less dense section of air to a more dense section of the air, which means that the light will refract in a downward direction as indicated by the dotted red line, and not continue on a horizontal path into the observer's eye. So according to the above, the two scenarios shown below cannot actually happen on a globe Earth. An image of the object would not actually be formed, and not surprisingly, such images have never been observed and recorded. There is no situation using the accepted standard conditions that result in a superior mirage that will allow the object of the superior mirage to be seen on a globe Earth model when the object is hidden behind the curve. If you think you can make the optics work, please try using the following proven conditions. A ray of light refracting in a downward direction into the observer's eye produces an upward inverted image. B. A ray of light refracting in an upward direction into the observer's eye produces a downward inverted image. C. A ray of light not refracting when entering an observer's eye produces a non-inverted image. D. There is a layered stable density gradient of less dense warm air over more dense cooler air, an inversion. E. The usual optical principles apply. F. The sea must finish up level and flat relative to the observer's line of vision. G. The images produced must match what is observed in real life. Good luck! Applying the superior mirage antecedent to the observation. On a globe Earth, the Shetland crater at 13.9 miles away should be hidden from the observer's view, but the object, the Shetland crater, can be seen as well as an inverted image above it, a superior mirage. This observation could not have been carried out on a globe Earth with a radius of 3,959 miles or 6,371 kilometers. The last image for those with a sense of perspective. Final analysis. 1. The geometric horizon has been shown behind the base of turbines and substation legs at various distances ranging from 8 to 11 plus miles. 2. Ships, objects, are observed that would not be visible on a globe Earth. 3. The logical antecedents for inferior and superior mirages have been presented. 4. Using ray diagrams and following the known laws and principles of light, as well as the observational conditions of the globe Earth model, it has been shown why the recorded images of Shetland crater's ship, the object, below the inverted image, the superior mirage, cannot happen on a globe Earth. These observations are not possible on a globe Earth with a radius of 6,371 kilometers or 3,959 miles. There is nothing more I can show or present. My sincere thanks to Karen B. for her technical support in this production. Dedicated to those who continue to freely question and discuss.